And as long as I hear from your presentation, it seems that the smoke or toxic gas motion is not affected by pedestrian motion. And I think if it is acceptable as a first order approximation, but looking at that phenomena precisely, I suppose that the smoke propagation is also affected by pedestrian motion. For example, if the pedestrian concentrate to the door, for instance, then the sectional area of the opening of the door is narrowed. Then the smoke passing through the door is different from the smoke calculated under the condition that the door space is completely empty. So, could you make a comment?
I agree. There may be some cases where that's going to be important. And in fact, what we now have is we're developing, we have a static link between smart fire and the evacuation model. So the evacuation model and smart fire, the fire simulation model, can talk, but it's a one-way conversation at the moment. What we're developing is a two-way conversation. So the people movement, if in the exact case that you mentioned, they block an exit, that can be taken into account in the smart fire calculation. If the people open the door in the simulation, then the fire simulation can feel that as well. We haven't got there yet, but we're actually developing that two-way link. At the moment, we've got a one-way conversation.
Thank you.
Any other questions?
Adam Brumley, AMOG Consulting. Ed, I noticed in the plots that you put up, and it might be worth putting them back up again, that you had fatalities with number of with time, and when you compare the two plots from observations.
Which one is it?
I haven't got the text with me here. It's basically with time. Yeah, one of these. Maybe the previous one, or well, that one will do. Looking at timescales there, they are different, so it's hard to tell. But if you had them on the same timescales, would those growths in those parameters map on top of each other? Is that something you've looked at? They appear to, just from observation.
No, they're actually displaced by a fair amount. So, for example, if you're talking about these curves, this curve, these curves, and this curve, this is starting off at about 300 seconds, and this is starting off at about 150.
Yeah, I guess that's because you've got fundamentally different systems. I think maybe the previous one where you had the same system but a different number of people. The reason I asked the question is there might be opportunities for rapid sort of conclusion on to how many people can occupy a system under an environment.
Is this the one you mean?
No, there was one with.
Yeah, but I hear what you're saying, and yeah, I mean you could do that. You could actually say for these sorts of design fires, but it's going to be based on your design fire.
You
could put in a design fire
and a system, and then say
well, how many people should I have in this structure for this design fire?
Yeah.
But you've got to really then do a good risk analysis to identify the types of fires likely and so on, and do it that way. Yeah. But fire is not the only reason that you limit the number of people in structures. Yeah, there's other safety reasons as well.
Yeah. But it might be something worth exploring in your journal, just with the data if you've done so many runs.
Yeah.
Ed, what did you use as an FIH of 1, the fatality?
Sorry?
What limit value did you use for heat dose that would kill?
We use the we've got two triggers in Exodus. We've got the trigger that you tend to use, which is you begin to feel a bit uncomfortable, and we
severe pain is the expression.
Well, you call it severe pain, but other researchers call it something else. But it's the pain threshold. Right. And we use that threshold when people, for example, are in an enclosed room and they're going to make a decision: am I going to go out in the fire?
Sure.
But when they're immersed in the fire, we use the threshold that causes death in, I can't remember the percent.
Third degree burns?
Yeah, something like that, yeah.
Because it's interesting that it looks as if you've sort of overestimated the fatalities.
Yeah.
And of course, actually to kill people with heat, you know, the conditions have to be really extreme.
Well, actually, they're not actually dead, are they? I mean, they're incapacitated. So it's actually
Right,
saying,
so-
that, and then they're going to die eventually because no one's going to pull them out.
Yeah, so that's I think
Yeah.
there's some interesting things there. But I would feel that you know, there's a big underestimate here of the toxic gas side of it in this particular analysis.
Well, it would have been
I
really
think we
nice
need
to
work on that.
put the hydrogen cyanide in
Yeah,
this as well.
yeah. Okay, I think lunch is calling, unless anybody has anything they really want to ask. Okay. Thank you very much indeed, Ed.